Hey guys, this is Kyle with Maximum Effort Robotics. We are going to go through our kit assembly, our Synthwave kit assembly today, and we're going to start off with the weapon motor to weapon hub assembly. In fact, we're going to go ahead and assemble the whole weapon hub here. We are going to need, of course, the weapon motor assembly. We got the stator and the can. We've gone ahead and cut the weapon shaft off the can because we are going to drive it using the friction fit on the can itself. We've battle hardened these as well, run epoxy all through our windings here, around the magnets, or around the windings here, around the magnets inside the can itself. And that gives really a lot more durability to the weapon motor. I've run a lot of these. I've run this weapon assembly, these motors, battle hardened in a lot of fights. I've only ever had 2 failures, and that's probably in 30 to 40 fights. And those are mostly due to continuous use, continuous wear. So we're gonna need those. We got our weapon discs here, AR 500 3mm weapon discs. Then we have our hardware here, and you're gonna need, tool wise, you're gonna need a 2.5mm hex key or Allen key, and a 7mm socket. We're gonna go ahead and start off with the installation of the can into the weapon hub. There's a lot of ways to do this. I usually prefer to use a vise. I'm going to show you guys the most accessible way, which is really starting to press it in there. And then that one goes, I can honestly probably press that one all the way in, but I'm going to show you guys that I'm not afraid to use a hammer with this setup. Make sure we get it all the way seated in there. I'll locate a spot like this one where I have a hole in a piece of wood. You can really just take a 2x4 even and drill a hole big enough for the shaft to fit in there. And use that as a backer to hammer it down on. You don't hammer it too hard, pretty light taps. And the can is going to sit just shy of flush with the hub. It's actually looking a little bit off center there, so I'm going to go. And you'll see here it's not going to come all the way flush in here either. That's where our bearing, support bearing on the other side is going to sit. And the bolt that we use as a dead shaft on this side goes into the bearing. I wanted to have room to sit all the way through the bearing so that it wasn't being knocked free on impact. So that's inset still a little bit from flush with the inside of the hub here. Now we're going to go ahead and install the hardware. I'll install the blades using the hardware. If you see here, it's keyed to the blades so that you're not really putting all of that impact torque on just the bolts. It's also going into the hub itself. So we'll go ahead and put both of those on there and then snug that down. So when we install the hardware, we install it with the nut on the side that the motor is on. That's because you're going to have more clearance on that side because of the motor mounting to the inside of the frame. You'll have a little bit more clearance on the side that the motor mounts to have those nuts spin, not impact the side wall on the frame. could probably shove these through here, but I don't want to really rough up or widen out the print any more than I need to. So we're just going to go ahead and take the time to screw that in there. And you'll notice you do get a little bit of a bite. It could stay for show without needing the bolt or the nuts, but no, definitely not for use that way. Go ahead and spin the other one down in there. This would be a really good time to have a drill, but that is okay. We're nearly there. Alright, now we're going to take the nuts here, start them, just hand start them on this side. So these bolts are custom cut down to length. I don't haven't been able to find any that are the exact right size we would need for this kit, so I just have a jig to cut them to length. Oh. There we go. Glue. Have a jig to custom cut them down to length. Make sure that they are the exact right size. Once that starts to snug down, these are nylock nuts as well, so they, you can see here. Oh, focus. There we go. They're nylock nuts, so they don't back out on their own. I have tried using standard nuts with Loctite. I don't love that because I don't want to be fooling around trying to clean Loctite out of threads or bust it loose when in between fights at an event. Rather just be able to spin it free when I want to. Alright, now they're both decently tight. I'm going to go back and get them torqued down. You can torque them down pretty good. This is print is a solid 100% infill carbon fiber nylon print, so you can really torque away at it there, and you're not going to get warping. You'll get a little bit of compression, but I'm okay with that as long as it's uniform. I'm okay with that. And we will actually be installing this all as one piece, so I'm going to go ahead and pop the rest of the motor in there, and we will get on to the rest of assembly. Installation of the weapon will actually come a little bit later. We'll jump right along to there. All right, we just finished the weapon motor assembly, and we're going to go ahead and do the drive motor installation here. I do drive motor installation next because you do a good bit of probably most physical handling of the item when you're doing drive motor assembly. These are press fit TPU printed motor hubs, and they can get a little bit tight, so we're going to go ahead and put that in here. What we do is we're coming from the back side. There's a set of notches here on the back that lock in around the gearbox here. These are the motors that come with the kit. They're 22.2 to 1 FingerTech silver sparks. and it actually designed this hub specifically to fit this exact motor. And then there's, if you look down in here, there's actually a lip on the other side. It's kind of hard to see, but this inner diameter here on the very edge for about 2 millimeters is smaller than the rest of the diameter for this can to sit into, so it can't actually be pulled out. Can't be pulled out, can't be pulled in. It's a real bear to even get it in there, so we'll go ahead and go through that process. We're going to, one of the nice things about using a flexible filament is we can flex that motor in there, make sure that our indents here on the print are lined up with the flats on the motor. And we're going to come in from the side here. Press until snug. It's in there. Do the same thing with the other side. You can see here that that lip here where you can't quite see the edge of the gearbox. These drive shafts are also trimmed to length so that they do not protrude past your direct driven rear wheels. Let's go ahead and get, there. Let's see, next step, those are in there. I do install them in this vertical orientation so that there's more room for activities. So there's more room for getting the other electronics in here in this area. And there's still plenty of room. I tucked the, we'll get there, but I tucked the drive ESCs up underneath them. They fit pretty snugly up under there, and it's their home. All right. So next, let's do the axle assembly for the non-direct driven wheels. I'm going to grab a few pieces here, a few tools, and some hardware. I currently have, let's see, all the hardware stored together, which seemed like a good idea at the time until I need to find the things that I want to install now. So I end up dumping it on the table. That's not known. That's all right. Right now we're just going to use two of our screws here. Our hex screws have the exact sizing. I'll have to list it in the details of the video here. So what we're going to do is, you're going to need actually two hex keys for this. You will need a pair of 1.5s, and we'll get to why we need a pair in a second. We're going to start off with a right angle one. All of them needs to be right angle because you're going to have to get in here. That is awkward spacing. So we're going to take one. We're going to put one of our washers here. And we're going to feed it through from the inside of the frame. Actually, I may have to feed it through with my finger. I'm going to feed it through from the inside of the frame to the outside. This is going to be our, there we go. Trying to make sure that's all on camera there. We're going to go on to the weapon assembly next. I've already installed the flanged bearing here. I like to use flanged bearings because it allows for if there's an impact or wear that kind of loosens this inner race here on the hub. So long as there's good friction from the outside, you're not going to lose this bearing here. It's going to stay in place and it's not going to shift inside. I went ahead and put on a tighter fitting heat shrink here to help with feeding these wires through this hole. I'm going to go in. Go in here. Once that's gone in, I'm gonna just get them up to where I can reach them. I'm not really applying force, just wiggling them to get them in here. Push that a little bit in. I'll show you once I get this installed why that hole is tight enough that I have to go through all that. I'm actually going to go ahead and put the dead shaft in on this side before I even start trying to put in the hardware to mount the motor, because it helps to stabilize the motor, keep it rotating around the center so I can line it up easier. This is an M6 bolt, M4 driver. I'm just going to go in enough to make sure I'm in that hole in the center of the flanged bearing. I think we are there. Okay. Now we're going to grab our, come back to, I believe, the 2mm driver. I've got my mounting hardware for my motor here, and we're going to just start in on this. There are holes from the outer here all the way in. You can see it's not big enough for the whole screw to fit through. It is big enough, however, to start them from the inside and then finish them from the outside. So what I do is I grab these pliers here, just get them lined up, and because it's printed, you can actually kind of, I have to print them a little bit small, the holes there, kind of push it in and it'll hold it in place till you get here with your hex driver. You can tell it's started to bite. I'm not going to tighten it all the way down just yet, because it's a lot easier to get them all started and then tighten them all down. Second one, which is bottom right. There's no particular order, that was just the second one I got in there. It looks like we're actually pretty well lined up because I didn't feel that skipping. Number 3. Nope. I'm trying on me there. Okay, so I ended up propping the axle into one of the wheels so I could hold it still. Line up the screw inside with tweezers. See the head from outside, and go ahead and get that driver in there. Now it is tightening down. And finally, our last, hopefully less eventful bolt here, screw. Drop this thing as many times as I can. The one thing about filming this is I have less light right here, so see our hole is right there. I just gotta get a screw in that. So worked last time, why not try it again? And this method is batting 1,000 here. Like that. light from above, use some tweezers to line it up in the hole, and just push the driver through. We are going to go ahead and snug this down. So I do like to, when doing final assembly, I do like to throw some Loctite, some blue Loctite on those, just to keep them from backing out. But as you can see, run smoothly. You can see right here. Oh, let me get a shot of it. Get a shot of it with bright in the background. That clearance from that nut to that wire, that is why I have that hole where it is for the wire running, and why it's so tight. Does not rub. There's a good amount of clearance there, but just to make sure. I hate to take your own wires out while you are fighting. Now we go ahead and attach our weapon ESC to our weapon. Okay, so I'm going to run the heat shrink over, all the way over. Because we are going to have to do receiver on full testing with everything before we heat shrink anything, except for this connection right there, which I did off camera. So we are going to, that way we can make sure that everything is running in the direction we want it to. Anyway, that's an easy fix. If anything isn't, it is switching two wires. Pretty much, no matter which motor isn't running the way we want it to. That is not an acceptable connection there. Let's try that again. You know what? I just don't like the length of that black wire. It's wanting to shove into other stuff. I don't like to cut weapon motor wires because they're, you don't really have the option of replacing them, so to leave them full length if I can and just adjust very sparingly when I have to. But this was a have to, so just refreshing the solder on those two joints to help flow. That's better. And now this last one. All right. That's done. I'm gonna tuck that down for now. I'm gonna want this in the future. Tell you what, I'm actually gonna go ahead, skip to installing a plate, armor plate on the front because I want to tuck this ESC up here to install the switch. So let's grab some hardware and get going. Here I've got 1mm titanium plates that I bent. It's grade 5 titanium. And I've got some UHMW backers here, and these actually go inside the frame of the robot. I learned this in beta testing that this is a good method to distribute force applied to the armor throughout the entirety of the front of the robot. So instead of there being screw holes here and that portion of the printed frame bearing all the weight, all the force when the plate is impacted from that screw, the force is distributed evenly amongst this whole front plate area because of this just being passed through. The actual connection from the plate is into the UHMW strip. I recommend having a pair of pliers around for this assembly. It can be a to-do the first time. There we go. Ow. Hey guys, screwing into your finger hurts. I don't know if you guys knew that. Don't recommend. Just gonna nudge this guy over a little bit. All right. Did a really good job of keeping that on camera. The give and take of tightening one, loosening the other, tightening one, loosening the other, until you have some flex still left in here. I don't want this to be flush up against that, because then you're going to be transferring all of your impact, no matter what, into the frame. I want the impact in the plate and in the UHMW in here. That's where all the force should be. Okay, that one's in. This one we have less things in the way. Probably going to back out this bolt when we go to install that plate and put it back in after the plate's installed. For now, we're going to tuck the wires there. Put our switch in. So we've got two different switches that we use in this. One of them is the fingertech switch, and this one is, I believe, the Inbots switch. It's a flat switch, and I've made an adapter plate so that we can keep the same mounting holes in the same position, at least in general on the robot for the on-off switch. It's going to be in the top plate here every time. That's where your on-off switch is going to be activated, deactivated, engaged by you. So we're going to go ahead and install this switch mounting here. I just made a mounting piece and mounted the flat switch to it here. So it's reference name, and all of our documentation is flat switch. We'll get files for the actual mounting plate, and then let's see, this is the branded painted lid that will be included with each. This is a blank lid, no branding, just for you if you guys want that option. And you will receive files with both of these lids for each of the switch types. So you'll have the files for both switch types. I will include with the kit the lid, the physical lids that go with the switch type. I include with the kit. So you have all the options open to you. We'll be wiring up the plug here, my XT30 connector. Let's grab a bit of heat shrink. So that was a shock, but we're gonna go ahead and tin these wires. I think smarter, not harder. If you plug the connectors together, you prevent the heat from being I'm trying to solder with a wire. You plug the connectors together, you prevent the heat from focusing so hard in one place that it's going to melt the plastic. Which is a really weird way of saying you help dissipate the heat better. Not right now. Positive. I'm going to go ahead and feed this heat shrink on here because it is super hot right now and will likely shrink right up for me. A little bit. Throw some. Test fit here just for length. Don't need much. So go ahead and tin this side also. I may have skipped ahead a little bit with that, but I got on a roll. Alrighty, I'm going to tin this. Good solid connection. Slide the heat shrink on and all right. Side's gonna come down and let's say it goes. I don't know where this one goes. I guess we can. Let's work with that length. Tin this side and go ahead and slip on our power distribution board. I mean, that's not the word. Slip on our heat shrink for our power distribution board for the negative side. And then we will go ahead and tin our power distribution board for our negative side. This is a rectified robotics power distro board. Purpose built. It's very handy. Have the right number of contactors for doing something like this. Let that cool for a second and then go ahead and tin the other side before we do any installation. Actually, I lied. It doesn't have quite the right number. I could use one more. Use one more terminal because we are running to the. We've got battery incoming here, and then we have 3 on this side. They're all ESC negatives, which is accurate. 2 for the drive, 1 for the weapon. But I'm also going to tack on this side with the battery negative. I'll go ahead and throw on the one for the BEC, battery eliminator circuit. It's what you use to power your receiver. That gets hot. This is our battery eliminator circuit, also rectified robotics. It's a 2 amp, 2 to 8 cell, 2 amp battery eliminator circuit. And I'm going to go ahead and install that guy. That's not the right wiring. Grab the smaller gauge wiring, but I don't. You could do that with the BEC, but I don't. I'm not going to be sending out multiple gauges of wiring. I'm just going to send out the one. So I'm going to use the one to show you. You know what? Let's go ahead and do the run to the other power distro board before I jump onto that BEC. off the output of the switch. Run that back underneath the switch. Give myself about the same length that I gave on the negative side. Oh, did that out of frame. Give myself about the same length that I did on the negative side to power distribution board. And now we will tin that wire, get it set up, and install the hot side power distribution board. Then we will move on to the battery eliminator circuit. This is where I develop a memory. I remember the hot thing make hot. And I remember that I need heat shrink on here. Now hot thing make hot. All right, now let's run the battery eliminator circuit. The BEC has markings on here, so just remember which side. It's got markings for battery, and then this side just has power markings. That's your output. This is your input. Tin this side as well. These can go pretty short. Actually, don't need to worry about installing heat shrink yet because the other end just goes to the receiver. So when it comes time to, I can just unplug that and slide it over and heat it down. So I just need to worry about I'm making these connections now. So it's tin these. Okay, it's good that failed because I did it completely off screen. Let's try this again. That's garbage. I'm going in from the opposite side that the incoming battery line was soldered from, but on the same pad. Alright, now the battery eliminator circuit is on there. Let's see, that's probably the next step. Next, let's go ahead and connect the weapon ESC to these power distribution boards. And no, we don't have the receiver plug that in yet, but we will. Kind of looking like the way things are laying, it's going to be easier to get things on from this side. So let's slide our heat shrink across the power distro board. To this side. Now I can more easily get these things in place, and then once everything's soldered on, I can slide the heat shrink over. Oh, do it again. And this is a little bit snug here, trying to move these around because the heat shrink for the weapon ESC is right here. That's not going to stay that way. We'll have a lot more breathing room. All right, now we can get our, let's go ahead and wire up our, pop this back out, wire up our drive ESCs. Alright, so remember we talked about, we have white, orange, black, and it's going to be effectively white, red, black. White is our signal, red is our power, and black is our common, negative. So we run out of solder here. I may have to do this one as example and then do the other one after I get some more solder. So got a 3-pin receiver connector here. It's got the 1 pin for signal. That's all I need, all I want for this. It's going to receive our signal from the receiver and run it through to the motor. Alright, got common. I said common. This is not common. This is hot. This is red. It is it's late for me here, so disregard when I say things that don't make any sense. Let's see. We're gonna slide in here, right there. Maybe that should be enough. Go ahead and tin this out. I don't think I have enough to actually make the connections. So what I'll be doing for the remainder of this ESC is duplicating what I just did with this hot wire with the common, the black wire. Reinstalling the motor and making the connections to these power distribution boards just like I did a moment ago with the weapon ESC. This signal wire will remain loose for the time being, and I will connect that to the receiver when I install the receiver a little bit later on in the build. I'm going to have to set this aside, get some more solder, and I will pick back up momentarily. So now we're going to cover the finishing up of the drive ESC wiring. We started that earlier. We'll finish it up now and reinstall the drive motors. Now we're going to mock up our wire length for running them into the power distribution boards. This is a spot where a pair of these helping hands is really helpful. Now we're going to remove the old XT60 connector from this test battery I have here and put on the XT30 that we're going to use in this kit. Tinning the connector is always best done while it's connected to the other half of the connector so that we don't get melting of the plastic. When you're changing the plug out on a battery, always do it one wire at a time and cover the first wire before you go to install the second wire, unless you want a battery failure or perhaps fire. Now we're going to get everything kind of in place and make sure our heat shrink is covering the atoms, if not shrunk down, so we can go through testing with the receiver installed and make sure that all of our wiring is done correctly, our motors are spinning the direction we want them to, and we don't have any bugs here at this stage. Now we're going to connect our right side drive to the receiver and our battery eliminator circuit to the receiver, and give this thing a test and see if the motor is turning the way we want it to. If not, we'll just switch it around at this point and get everything lined up correctly. Looks like it's turning, but it's responding the way I would want the left side drive motor to respond. So I think we're gonna switch it around here and try that again. Let's power this down. We're gonna try that again with the left side drive. Make sure that it's doing everything correctly. The wires aren't reversed there, and then we will see what we can do about getting the right side on the right channel as well. Alright, it looks like both sides of drive are responding the way we want them to. Now we're going to power this thing down and move on to weapon testing. Here we have the robot clamped to the desk. I'm just going to power it on and run a super low speed test just to make sure that the weapon is rotating in the right direction when we move the stick. And it looks like it's responding how we want it to. We will move on from here. Now we're going to back out the dead shaft so we can go ahead and install the other armor plate on the right hand side. The head of this bolt interferes a little bit with getting that armor plate installed, so you want to do final installation of the bolt after that armor plate is in place. We can take a little bit of time here to line this backer up and get the screw in through the frame, but it's worth it. The weight or the force distribution that this backer plate allows really makes it worth the extra time to get things lined up properly, and it makes this makes the chassis last a lot longer through fights because you aren't having all that impact force in one spot. It's being distributed across the chassis as much as possible. Now we'll get the dead shaft installed back in there, fully supporting our weapon. And now we can move on to wheel installation. fooled around with a number of things to get the wheels to stay at the proper spacing from the frame. And springs are something I came to first on my Beetle weight, but now I've used them on this as well. They will keep the wheel from rubbing against the frame in a normal case, but also allow it to move in if impacted by something, and lessen the impact force absorbed by the axle or the chassis itself. Now on final installation, I use blue Loctite on the screw going into the axle from the inside of the chassis. I don't typically use any on the screw going through the wheel on the outside of the chassis, but you may if you end up having issues with it backing out. I haven't run into that, but that's an option. Now you are going to want to put this belt on at this stage when one wheel is on the side, and go ahead and loop it over like so. I'm going to say it and not do it. Loop it over the back axle also, so that it is in place when you install a second wheel. A little bit of trouble there. Let's make sure, get that lined up. The white dot needs to line up with the flat on the D shaft. That's how it's designed, and it'll fit on and stay pretty solidly that way. Now we just get the belt into the pulley channels, and we're ready. All right, now is the time when all those years of Tetris pay off. We're going to get the electronics into place. There's not necessarily an exact spot for each one, but I generally will put the weapon ESC in the left side, kind of up in front of the switch. I'm going to get the drive ESCs more or less underneath the drive motors. We're going to do the receiver in the right hand front bay, kind of opposite of the weapon ESC. The battery is going to go right behind the weapon bay, right up against that wall, and then between the battery and the drive motors will be the power distribution boards and the BEC. Now this may take some doing. You're going to want to just have some patience here and understand that you may have to disconnect and reconnect some things to make it fit well in there. But I do find that not rigidly securing anything to the chassis gives your electronics a better chance of surviving shock. So you're not going to get jostled around as much if you have a little bit of room to give. And there it is, all in place. We're going to go ahead and throw the lid on. Now again, this kit will come with one of these lids, which is my branded lid, and a non-branded lid that you guys can use if you prefer. Of course, you know, I love to see this one out there running around causing havoc, so if you guys are up for it, throw this on there, win some fights, send in some videos. I love it. Now time for maybe the most important part, which is the weapon stop rake, a la Hypershock. You can see safety rake in place. I'll turn this thing on and give it a little test run here. And that's it. Check out the shop link in the description. Make sure to check back pretty frequently for updates and updated videos. And we will see you guys later. Go out there and have fun.